the hope is that we're talking about it, right? We and many other people are talking about this as a problem, because if we can create a public upswelling of unhappiness about major reductions to support for fundamental science, those reductions will not happen. There is power in numbers that, turn all those blue faces yellow, get them marching, get them writing to their MPs, get every physics student, get every physics teacher in the country writing to the Institute of Physics saying, we don't want this to happen. It's not a decision that's irreversible.
Welcome to Newsnight, the podcast where we delve into all things particle physics. Do you want to know what is going on at the Large Hadron Collider? Why scientists want to build new, massive particle smashers? Or how particle physicists are seeking to answer some of the biggest open questions about our universe? If you answered yes to these questions, then you're in the right place. I am your host, particle physicist, Dr. Sam Gregson. In this podcast, we will cover cutting-edge particle physics research, the fascinating future of the field, and interview active physicists attempting to unravel the deepest mysteries of our universe at the very smallest of scales. Welcome. Now let's get into the quantum weeds. What's up, you scholars of enlightenment? Dr. Sam Gregson, particle physicist here again. I hope you've had a brilliant week and have an exciting weekend in store. Now today, unfortunately, we're going to be discussing the disturbing news of UK science funding cuts. UK Research and Innovation, the UKRI, the umbrella organisation that controls UK government investment in science, has paused or withdrawn UK investment in 4 large-scale physics infrastructure projects and thrown British participation in major international science facilities into doubt. Despite being promised funding of more than 280 million from UKRI, the projects now face being defunded, impacting hundreds of potential research jobs, many for early career researchers. In addition, one of the science councils overseen by the UKRI, the Science and Technologies Facilities Council, or STFC, faces a potential 30% cut in funding for grants and its work in particle physics, astronomy, and nuclear physics. Higher energy prices and unfavourable foreign exchange movements have increased the annual cost of the projects and facilities overseen by STFC by more than £50 million per year over the period of the previous government spending review. And the current government is demanding that STFC find savings of £162 million in its budget by 2029 to 30. That's more than £40 million per year to bring itself back into line. To help me understand the nature, origin, and impact of these cuts, we're rejoined by a phenomenal special guest, Professor John Womersley. Professor Womersley is a special advisor within the College of Science and Engineering at the University of Edinburgh. He worked at Fermilab before becoming a scientific advisor to the Department of Energy in the US. He then returned to the UK in 2005 to become director of the Particle Physics Department at the STFC Rutherford Appleton Laboratory at a time when it was building and delivering vital components to CERN's Large Hadron Collider. In time, Professor Womersley took on a broader role as director of the Science Programmes Office and was then appointed chief executive of STFC in 2011. He has also served on the councils of both CERN and the ESO, and the board of the Associated Universities for Research in Astronomy. He's chaired the European Strategy Forum on Research Infrastructures and the European Commission's expert group on cost control and management in large research infrastructures. He's also served on numerous review panels and boards as an expert, including for the Helmholtz Association and the Human Brain Project. He has seen how large-scale projects get delivered. So who better to help me understand just what the hell is going on? John, welcome back.
Thank you.
Why do we always meet under such awful circumstances? So last time we met, we were worrying about a new collider at CERN that might not get funded. Now we're witnessing the slashing of UK science budgets. I'm sorry to always bring you on under a cloud. What's going on there?
I don't think the FCC was under a cloud. I think we were agreeing that it was excellent science, and we were debating the best way to explain that it should be funded. This is a much more difficult situation because we're following up on some really severe and concerning announcements of reductions in funding for particle physics and nuclear physics projects within the UK. And this is something that you really don't want to have to react to. But given that it's been announced, it is important to explain what's going on and encourage people to not accept this as a done deal, because I think there are ways that the community could and should push back. And I think public support is also quite important here.
Absolutely. So, John, before we get into the specifics, let's get down to business. How did we get here? We have the UK ripping back its planned contributions to international projects, potentially deep and long-lasting damage to UK science and the UK's reputation on the international science stage, a Science Research Council which is having its arm twisted to enforce severe short to mid-term austerity. What on earth is going on, John? Before we get into specifics, how did we get here?
All of the above. So what we're seeing, I think, and I should emphasize, I don't have any special inside track here. I did in previous part of my career I was responsible for running STFC, so I'm acutely aware. STFC is the funding agency that we're talking about here. I'm acutely aware of the challenges. This is not an easy organization to manage because it has lots of conflicting pressures and lots of fixed costs that are hard to deal with. So what we're seeing today is an attempt to deal with some unforeseen extra costs that the science program in STFC is being saddled with. And some of these are completely outside their control, like industrial electricity prices and the fact that the UK government has increased national insurance contributions, so staff cost more to employ. Others are things that they did decide to plan as part of their program, making optimistic assumptions about future budgets. And those optimistic assumptions turned out to be over-optimistic or reckless, depending how you look at it, or risky. But you don't achieve much if you don't take a few risks. It looks like the risks they took were more than they should have. So STFC bid for and was planning on and made a lot of commitments on the basis that its budget would go up in a government spending process which has just finished. And instead of a budget going up, it got a budget that's roughly flat in cash terms, which means it has to swallow the impact of inflation. At the same time, it's got a lot of costs that are increasing, and it's made some future commitments that could only be funded if its budget went up. So convergence of all those bad things at the same time has led to what I guess we would describe as pretty draconian measures being proposed to try and get the budget to fit within the envelope that STFC has been given. 30% reductions in the grant funding that goes to university groups active in particle physics and astronomy and nuclear physics, and pulling back of support, which had previously been indicated for 4 quite prominent research projects. And we'll talk about all those in detail. So what this is a decision not to give STFC more money, coupled with some optimistic assumptions that STFC made about its future, coupled with the world outside becoming more expensive to work in. International foreign exchange contribute. Yeah, it's not perfect in any sense, but it is a convergence of things. And probably any one of these could have been managed. Maybe 2 of them could have been managed, but the whole lot together is threatening to turn the ship over. And this has been known about, I think, internally for a while, but it was hoped and it was assumed that the consequences were bad enough that government would take some steps to avoid it happening, and that has not occurred. So you could say a decision was made not to help here. There's certainly a suspicion in the minds of some of our colleagues in the research communities impacted that if they'd been medical researchers, if they'd been people working in material science or areas that had a closer connection to AI or some of the government's future priorities for economic growth, they might have been given some additional money to help. Particle physics and astronomy, I think, reading between the lines, are seen as somewhat remote from connection to everyday priorities. Yeah. And therefore, if a problem appears to have arisen in that part of the research funding landscape, then it's not going to get helped from outside. But that's a little bit unfair because these are not problems that have arisen in particle physics and astronomy. These are problems that have arisen in the operational costs of some of the other big facilities that STFC is responsible for, like the Diamond Light Source and the ISIS neutron scattering facility. And those very much do help the areas of research that connect directly to industrial policy, material science, biomedical research, pharmaceutical research. So it's a lot of the people who are being asked to contemplate these big reductions feel that they've been unfairly singled out, maybe not targeted for hurt, but not given the help that might have been afforded to them. And we should also mention that there's multiple layers of authority here at which decisions are being made. So your little video clip there shows Ian Chapman, who's the chief executive of UK Research and Innovation. That's an umbrella organisation responsible for something like many billions of pounds per year of science and research funding for everything that happens in the UK. And UKRI, within its budget, has about £800 million that goes into the work that STFC does. If UKRI had decided to turn that 800 million up to 840 million, none of this would be happening. So there's a treasury allocation to UKRI, which comes with lots of lines, and one of those lines is STFC. But there is also the possibility within that much bigger budget of doing things that might help in this area. And I think if there is a way forward here that avoids some of this damage, it's probably exploiting the fact that we've got this umbrella organization, which has a lot of money that hasn't yet been committed. And it could be, persuaded, arm twisted, pushed to change the allocation of some of that funding.
Interesting. So that's the higher level discussion that's going on. So let's jump into some of the specifics. So UK Research and Innovation, the UKRI, as you say, the umbrella organisation that controls UK government investment in science, is slashing budgets, and it seems to be doing so in two main areas, those being infrastructure projects and grants, particularly at STFC, as you mentioned, one of the councils underneath.
It's not entirely, and there are indeed
yes.
pressures on biomedical research and the Medical Research Council as well. So there's again, not a perfect storm, but a convergence of things happening. There is a shift away from the kind of historic way of funding research in the UK, which has depended upon academics writing proposals to funding councils, and those proposals being assessed on the basis of peer review, a peer review panel of subject experts in that same research discipline, and funding allocated then for 3 or 5 year projects to deliver research outcomes. UKRI is shifting some money away from those things to what they call missions and challenges, which are longer term projects, more working closely with industry or more closely related to government priorities. So it's not entirely clear how the funding will be allocated in those areas, but it probably won't be through this same mechanism.
Interesting.
That reflects manifesto commitments. It's been talked about as a priority by Patrick Vallance, the science minister, and Ian Chapman as UKRI head is tasked to sort of implement this. Now that accounts for what's happening in medical research and biological research, but it doesn't account for the severity of what's happening in particle physics and astronomy because of this perfect storm of other factors. The reason that STFC's budget is being held flat rather than increasing with inflation is because of this strategic priority to move more funds to other things. But as you correctly say, there's two other things then that are there's more than flat reductions, less than flat reductions foreseen, both in the capital spending, which goes into infrastructure projects. These are funded through something called the UKRI Infrastructure Fund. That's a pot of money set aside by the Treasury for capital investment in science projects. The Treasury accounts for capital investment differently than they account for the operating expenses of things. And this is true government-wide. If you're building a motorway, if you're building a new hospital, the building is capital. The people in it, the salaries are operational expenses, resource money, various words for that. And these are different because the capital investment is seen as a future asset. You've built something with the capital, and Treasury accounts for it differently as part of the public sector borrowing requirement in order to think about interest rates and things like that. So money that's allocated for capital can't be used to pay salaries. Money for these big projects, these four big projects, is from that capital pot.
Right.
And to bid into the capital pot, you have to have a sponsoring research council. You have to have one of these areas of research that says, yeah, we see this as an important area. And these four projects were all sponsored by STFC. So it's hard not to see it as a sort of targeted, maybe not assassination plot, but the things that were funded by STFC are being...
So this is, as you say, this is one of the first things that we're going to discuss. One of the two areas that basically is getting some of these savage cuts is four big projects.
Exactly.
Four big physics infrastructure projects coming from this infrastructure fund.
So let's talk about them.
Exactly. Which are under STFC. So what are these four major infrastructure projects which are being shelved? Because they're worth £280 million, which is obviously a huge chunk. And they all seem to have a particle physics flavor, John. So what are we?
That's right. They have a particle physics or accelerator physics flavor, and they've all been sponsored by STFC. So there are two of them that relate to international collaboration in big international physics projects. There's the upgrade to one of the three detectors at CERN. This one is called LHCb. So there are three collider. This is
my old project, by the way. So I will just put my conflict of interest on the table as well. This is,
you can explain the science drivers.
Well, this is my old project. So linked to looking at the matter antimatter asymmetry that we see in the universe. Why are we here? Why are we made of solid matter? Where did the antimatter go? What are the differences between matter and antimatter? Rare decays as well. Basically a complementary experiment to discovery machines at Atlas and CMS. And as John says, in the upgrade to the Large Hadron Collider, there's going to be an upgrade to these detectors as well. And it seems that now, John, the UK won't be contributing to that.
That's what has been proposed here. So yeah, the Large Hadron Collider, very successful flagship machine at CERN, discovered the Higgs in 2012, being upgraded now to continue operating at something like 10 times higher collision rate, which gives you much more data to play with and gives you the possibility to measure things with much higher precision. The two detectors that are optimized for high energy operation, they're Atlas and CMS, focus on studying the properties of the Higgs boson in greater detail, and looking potentially at the interactions between Higgses and other Higgses, which is something that's a real test of whether the standard model of particle physics is correct. So those upgrades are not affected by this proposed reduction in funding. But the third detector, LHCb, which is focused on the decays of heavy particles, what's called heavy flavor, quarks that are short-lived and don't exist every day in nature, but can be made in particle physics detectors, and the subtle asymmetries between matter and antimatter, which go back to the reason that the universe exists in rather than simply having annihilated itself in a puff of antimatter and matter in the very, very, very early Big Bang. So this is fundamental physics of a slightly different nature.
Yeah.
It doesn't study the Higgs, but it studies fundamental properties and precision measurements of the kind that might tell us what we need to look at in accelerators beyond the LHC. So this project was approved in 2022. Money's been spent on it. Yeah. International commitments and MOUs have been signed saying the UK is going to build. You may know this better than me. I think it's roughly a quarter of the contribution to this upgrade. And to pull back now, even though there's a little asterisk, and I'm sure everything that was signed had a little asterisk that says subject to future funding approvals, because you're legally not allowed to make commitments with money that you don't yet have, and this money was not in the budget, and that's the whole problem.
But it was expected, right?
It was expected.
We've got 49.4 million over 8 years.
It was not expected that there would be a major change in the funding envelope, and it was not expected that there would be an embarrassing need to uncommit to something that had been committed to. So this leaves UK scientists in a real problem. It's the ones who are planning to participate in this experiment. They don't know if they will still be able to. 12
UK universities, I'm reading here, dozens, hundreds of postdocs and PhD students who would be working on this.
Now, maybe they'll still be welcome to work there, but whether there'll be an experiment for them to work on is not clear. It leaves CERN in a difficult position, especially because the Director General of CERN is Mark Thompson, who was the former head of STFC at the time when these commitments were made. So it's probably his signature on the UK MOU that says we're going to do this. Now he then has to negotiate with his successor over whether this commitment is not lived up to, and that's particularly embarrassing. So we'll see what happens, but it puts CERN in a difficult position. It puts UK universities in a difficult position. It looks like we're reneging on an international commitment that was made in good faith, and none of those are things that you want to do. I think the decision to maintain Atlas and CMS is probably based on a sense that the Higgs physics is more central to the mission of LHC than LHCb, but this prioritization is unclear, and it's not obvious how that was made, and you could defend that decision, but
there does seem to be a little bit. I don't know how you read this. Maybe I'm being cynical as an old LHCb person. That there does seem to be a pull the funds from this, make sure it looks like the big projects are going ahead. There's no problem with them. Everything looks good. As we go into the Future Circular Collider, it looks like everything's running kind of okay. The big projects can't be seen to fail, basically. But maybe we can dial some of the knobs on some of the smaller efforts.
There's a strong message within government to agencies like STFC when faced with this kind of funding situation, because UKRI disputes that cuts have been made. They say we've held the budget flat and you're going to have to live within your means. Okay, so I'm going to a restaurant. I found the prices have gone up and I haven't got any more money. And they're saying, don't salami slice. Don't cut 10% out of everything. Find one part of your program which is lower priority and simply stop that. So that's following these instructions. It's you can't have breakfast, lunch, and dinner. Choose one meal.
You can't have the bottle of wine with your meal now. You just have the.
Well, no, it's more like you can't have dinner. You can have breakfast and lunch, so don't have dinner, and that is fine if you're a breakfast and lunch person, but it's not fine if you were relying on dinner to feed you. So this is avoiding. They say don't do the salami slicing. Find entire projects. And eliminate them from the program rather than trying to do everything at a suboptimal level. And that's a justifiable way forward, but it means that if you are unlucky enough to be associated with a thing that is no longer part of the program, it's gone from 100% to zero. And that's pretty hard to adjust to in any graceful way. So the second project that we can talk about is a similar situation where we made the UK made a commitment, again, with the little caveat subject to future funding approval, to participate in something called the Electron-Ion Collider. And this is a project for experimental nuclear physics. It's something, I don't know how much you've talked about this on previous editions of the podcast.
Not a great deal, to be honest.
Exactly, because it's something that is not, it's like an unanswered question where we're not so sure what the correct experimental approach is, and it's a really interesting subject to talk about. We don't have time to talk about it in great detail here. But what's holding together the nucleus in all the atoms that make up the chemical elements of our bodies? We know they're made of protons and neutrons. We know the protons and neutrons in turn are made of quarks. We know the quarks are held together with QCD, with gluons that are exchanged between them, and that's a strong nuclear force which makes a proton a proton. But we're not so sure what holds the protons and neutrons together in the big lump of 12 protons and 12 neutrons that make a carbon atom, or the big lump of 18 protons and 8 protons and 8 neutrons that make an oxygen atom. They're more like Van der Waals forces. They're more like sort of the chemical analog of the nuclear force, and it's quite subtle and complicated how a nucleus exists. And so the Electron-Ion Collider is a project under construction at Brookhaven National Laboratory, which is on Long Island in New York in the United States, to collide an electron beam head-on with a beam of heavy nuclei, of not protons, but nuclei that get accelerated to relativistic velocities, and therefore probe the structure of the nucleus with high energy electrons in a way that will, we hope, offer new insights into nuclear structure. It's nothing to do with nuclear power. It's not to do with nuclear weapons. This is to do with what makes a nucleus a nucleus. And this is a new machine. It's a new probe. It'll offer an entirely new experimental window on this. And the UK nuclear physics community has been very clear that this is their highest priority for many, many years. They want to have access. There'll only be one of these in the world. There won't be one in Europe. And they want to have a way that they can be part of this project and contribute to it and get access to the data from it. And so if the rug is pulled out from that, it's not just pulling the rug out from this particular contribution to this particular project. It's threatening experimental nuclear physics in the UK, because this is one of the flagship projects and it's one of their highest priorities. And it's sending a message that we don't think that you guys are deserving of a future flagship project in this area as well. So that's, again, a big problem. The UK nuclear physics community has historically been supported at quite a low level, but pulls its weight internationally. It's very highly regarded and a sought after collaborator. And if one of these flagship international projects, again, is in a much earlier stage of construction than the LHC upgrade, and it may be possible for them to regroup in New York and find ways to go forward without the UK. But it's an embarrassing failure to live up to indicative commitments that we've made. And it puts our nuclear physics community in a really, really difficult position in terms of, do they have a future project that can attract students and postdoctoral researchers and maintain the kind of viability of the community?
Yeah. I think they said here we'd committed nearly 60 million over 9 years.
I don't know how much of that has already been spent, but it's a significant contribution to the detector. The accelerator gets funded by the United States Department of Energy, and despite what you may hear about savage cuts to American science, the funding for particle and nuclear physics is in reasonably good shape within that overall context. And the electron ion collider is going ahead. It's a high priority for the Department of Energy and for Brookhaven National Laboratory. And if UK scientists are not there, then we will miss out on participation in what's a new frontier of nuclear physics.
Yeah. Very, very disappointing. We also have a couple of others that are getting pulled. One being the so if we move on to the other ones, CMAS, which is a centre for mass spectrometry based at the University of
Liverpool.
Yes.
Is it Liverpool? No,
I believe it.
Sorry, this is a hub and spoke model. The next project we'll talk about is based at Liverpool. So CMAS is a project for UK researchers, and it's one about building and supporting next generation mass spectrometry, which means being able to. This is a very generic technique, and it's one that's used in a lot of chemical and physical analyses, geological analyses, looking at meteorites, looking at forensic samples, looking at bone samples. So what
quantitative chemistry, basically.
It's chemistry. It can be nuclear chemistry. It can be atomic chemistry. You can buy machines to do mass spectrometry that sit on your desktop. This is not what we're talking about. We're talking about here building cutting edge machines of the kind that can't be purchased. And the concept here, CMAS, was to build a sort of high-end national network of mass spectrometry facilities that could be accessed then by any researcher within the UK, whether the central location or the distributed hubs around. So this is it's drawing upon the expertise in accelerator physics at Daresbury Laboratory and proposing to serve a pretty wide user community of other scientists.
So if you don't have this at your university, you can go to the local hub and you can do this kind of analysis.
That's the concept. That's the concept. But it doesn't look like it's going to happen. Now, there are other funding routes for these kind of capabilities, and it's possible that some of what were foreseen as the spoke elements in CMAS will nonetheless go ahead. And I would see this as perhaps less of a disaster for future research capability, because there are ways that you could imagine delivering future mass spec capability without a big single project like this, and that might indeed be the way to go. So if I were to say, what are the biggest losses in this program, it would be the ones where we've got international commitments. And sorry to say, this is not one that that would fit that category, but it's still a shame not to be able to proceed with it. And the same is true of the final, the fourth one, which is a project called RUDI, relativistic ultrafast electron diffraction imaging, which is again, this is a novel technique. It's the idea that you can use an electron beam. You can scatter electrons off molecules or crystals or material structures, and not just look at the static structure in the way that the diamond light source does, for example, but you could, with very fast imaging, be able to see those atoms moving and vibrating or changing structure as chemical bonds are formed, as processes happen. And so that time resolved aspect, the ability to image things as they happen on the very fast timescales that chemical reactions occur, is a new frontier, and it's something that is just being explored in very high X-ray imaging facilities, like the X-ray free electron lasers in Switzerland and in Stanford in the United States and in Hamburg. But this would have been a UK window. It's a slightly different technique using electrons rather than X-rays, but a window into that sort of ultra-fast imaging. So again, based on particle physics accelerator technology, finding an application for that helps chemistry, biology, materials science, quite complicated and therefore quite expensive, and therefore perhaps a tempting target to be cut here. But it was it's a good idea, and it's a real shame not to proceed with it.
So you had a nice segue kind of into that. Can you give us any insight into why is it these projects specifically that are having their funding pulled? So we talked about, the government refocusing research priorities. Is this the government just not seeing these projects as linked enough to growth to the public? Or is it that these projects are too expensive? Or is it that these projects can go ahead if we don't contribute? Why have these four been singled out?
What we have not been given, and it would be fascinating to see, is the cost profile information that might indicate.
Absolutely.
There have been some hints that these four projects suffered unforeseen increases in costs and were going to come in as being more expensive than the original planning. I don't know for sure because we're not party to that. What we have also not seen is the full portfolio of infrastructure projects that are going ahead, though we know a lot of them, right? We know that Atlas and CMS upgrades are proceeding, so we can presume that LHCb was looked at in that context and was decided as, of the three LHC experiments, if we have to choose, one course of the meal that we're not going to order, LHCb is the one that had the least priority in some process that we didn't see.
I've heard some arguments there that, look, when you get the FCCEE, you will be able to do some of your flavor physics then anyway. So
personally, I remember when I was 10 years ago, when I was in charge of STFC, we challenged the LHCb upgrade collaboration, perhaps before your time, I don't know. Please explain why you will benefit from the LHC upgrade in the same way that Atlas and CMS will benefit from, because it wasn't completely obvious to a non-expert. And maybe those arguments are coming back. I mean, to say that question was satisfactorily answered, and certain scientific policy committee strongly endorsed that LHCb should be upgraded at the same time as Atlas and CMS. So the science is not actually in doubt. We also know, but we don't know the numbers, that there is a major upgrade project underway at the Diamond Light Source. We know that project is suffering cost increases, big cost increases, that there are pressures on the budget, the capital budget, from that. And so it's quite possible that the capital budget is overcommitted, and priority setting has had to take place within what you might call the STFC bit of it. And certainly it feels like we're only having announced reductions in infrastructure in STFC's area. But again, we don't know. Maybe next month, the Natural Environment Research Council will announce that there are major cutbacks to the Antarctic program. It could be that there are other things going on and we're simply not aware of. So it's caution a little bit against saying, only this area has been targeted. What seems to have happened is that the announcements in this area have come out, and there's some hints in Ian Chapman's testimony to the Science and Technology Committee that they were rushed out because of leaks.
Right.
So one feature that we know about the particle physics and astronomy communities, which we love, is that it is very interconnected, that people share information with each other, and that all the grants and programs involve large collaborative groups. So when something happens, it typically affects a lot of people. It affects a lot of people at the same time, and it therefore creates it gets communicated to everybody. And that means you have to make a big announcement about it. Yeah. If you are stopping funding for a lot of many small projects that are £100,000, you don't get the same sort of influence. And that's typically what happens in engineering and physical sciences, what happens in chemistry or biology. So let's wait and see. I am certainly concerned about things like the Diamond Light Source upgrade. I'm concerned about the ability of STFC to operate some of its big facilities. I'm concerned about the future of the High Performance Computing Center at Daresbury Laboratory, because these need big capital investments in the future. But we haven't seen any announcements yet, so we don't know if they're under threat or not. I don't think we should assume that anything is safe just because it hasn't been talked about here. But we do know that the things that have been talked about are probably talked about at the same time as other LHC experiments or other nuclear physics projects or what have you. So we're not looking at the whole picture, but the picture that we can already see looks pretty bad, and that's why we're acting to it.
Absolutely. So let's come on. So we talked about those big infrastructure projects. Let's get on to the STFC funding that we've talked about. So the Science and Technology Facilities Council, STFC, that's one of the research councils under UKRI and the one that funded my PhD. Thank you very much. It coordinates work in particle physics, astronomy and nuclear physics, and oversees related infrastructure, including the Central Laser Facility, the National Quantum Computing Center, and the Bowlby Underground Laboratory. So what are the cuts? We've kind of mentioned it a little bit, but what are the cuts that are happening at STFC? Because you talked about 30%, but I've heard that could get even worse.
Yes. So there are announced reductions in the funding available to fund university groups. We call these grants. They're research contracts, basically, that STFC enters into with the universities. And there's 25 universities across the UK that do research in these areas. And each of them gets writes a project proposal that describes what they're going to do for the next three-year research cycle. And they get money, usually less than they've asked for, because there's never quite enough to go around. But it sounds like this time around there's a major reduction. STFC already announced that certain grant programs are going to be delayed, that they couldn't issue the grants on the timescale that they normally would. And that leaves universities with 6 months or so where they have difficulty paying people. That's bad enough. But now it looks like the next round of funding, the next opportunity when everybody gets to write their proposal, is going to have a much smaller pot. And that, if we follow the same logic that we've heard up to now, either means that everybody gets about 30% less than they had last time around, or potentially 30% of those universities don't get any money at all. And neither of those is a good outcome, because in the end, you're losing capacity and capability in terms of our research base, but you're also going to be able to attract fewer students, fewer postdoctoral researchers, and do less science in these areas, because it's the university researchers who do the bulk of the real research work. And this is doubly bad because there's no indication that the grants program costs have increased. There's no real indication that there's been over planning. It's not like STFC have recklessly added a whole lot of new universities and said, we want to support a major increase in this area. And
so unlike the infrastructure projects where you can say that the costs have gone up, energy prices, we can't help this.
This is just something that is, in talking to colleagues at the Royal Astronomical Society, it's like, the grants were unlucky enough to be passengers in the car. And when the cost of petrol went up, I mean, it's not like the cost of the grants have gone up, it's the cost of other things that STFC does. And it's that list that I went through at the beginning. obviously national insurance contributions, electricity prices, the cost of running big facilities, the cost of international subscriptions.
Just while we touch on that, then John, does the defunding of these specific projects, and particularly in STFC, show that lumping particle physics projects, lumping astronomy projects in the same funding pot as these facility operations, that's always going to cause tensions? Should they have been decoupled?
So there are synergies that justify it.
Yeah.
You'd like the
particle physics needs big machines, like
particle physics needs big machines. You'd like the accelerator physicists to be in the same organizational priority setting as big machines that use accelerators, like the Diamond Light Source. You'd like the international subscriptions that pay our membership at CERN to be in the same responsibility umbrella as the people who use CERN.
Yeah.
But putting them in the same bucket of money creates some real problems. And it created let's not say similar, but an analogous set of problems in 2007 and 8 in the aftermath of the financial crisis, when science budgets had been increasing and suddenly they were not increasing anymore, and there was a STFC had to make similar bad, tough decisions without the existence of UKRI as a potential way to share the risk. And in the aftermath of that, I was brought in as chief executive a couple of years after that, and I agreed with my management team and the finance director with the ministry, the predecessors of DCIT, the current science ministry, that STFC would get its budget in future in 3 separate colors of money.
Right.
We got a color of money for grants, we got a color of money for international subscriptions, and we got a color of money to operate the big facilities. And we weren't allowed to mix any of these primary colors. You couldn't take the grant money and spend it on international subs, even if the pound lost its value. And you couldn't take the grant money to bail out the cost of running even if Diamond's electricity.
So you sort of have to deal with.
So we got our hands tied. We
Yeah.
voluntarily got our hands tied to avoid us getting into trouble. And that reassured the community. It was not just a PR exercise. It was a genuine legal restriction on how we could operate. But it gave great assurance to the particle physics and astronomy community that this.
You're not just going to let one piece grow out of hand and then.
You're not going to let one piece grow out of hand. So in that world, if you get a budget that's partitioned that way, you're not allowed to solve a problem stealing money from the grants. That seems to have been done away with, or at least circumvented in this year's allocations. Maybe the money was moved before the buckets were put in place. So I think there's a lot of questions to be asked about why that good practice was abandoned, and the philosophy behind it was abandoned, that you shouldn't punish this color of money for problems that are nothing to do with it. And legitimately, I think a lot of people in the research community have, people come, people go, people forget, but they should need to be reminded. We had a solution, and if that solution was abandoned, somebody who chose to abandon it should be asked, why the hell did you get that?
And we're gonna come on to why this might have been. There's one wider point here, John, as well, and you mentioned this when we were kind of talking offline. What is the point of having this umbrella organization like UKRI for science funding if it insists that when issues come up, you kind of solve it within one area of the budget? It just kind of says, you guys screwed it, live with the consequences. Why have we got this wider net if it's not going to kind of come into use?
So we got the wider net because in principle it can do good things by coordinating and acting together. But to me, having all of the money in one place gives you a freedom and flexibility to deal with crises in a way that doesn't magnify them, that reduces the magnitude of the impact rather than increasing it. And the UKRI has been quite clear that in its handling of this, that it sees it as an STFC specific issue that needs to be solved within an STFC specific budget. And this is the attitude I might take with my son if he overspends.
It feels like a naughty school child, right? You
feels very much like a disciplinary measure that you take with somebody who you think is irresponsible with their money, and that's not really a very mature attitude. It might be the right way to deal with a 7-year-old, but it's not the mature way to deal with an entire research community, especially since the decisions that that they are being, held responsible for were taken by Research Council management and not by any of the university researchers who
and sometimes are based on geopolitics or things outside of their control,
or stuff completely outside of control. As you say, national electricity prices to do with, the price of gas or transition to green energy. They need to upgrade the grid and stuff like that. And then, ISIS, the neutron source at the Rutherford lab, is paying very, very high electricity bills, along with any industrial electricity user in the UK. Nothing to do with the research budget at all.
Yeah. This is perhaps a very naive question, just to follow up on that then, John. But can the budgets not just be increased to cover the shortfall? Is that politically difficult? Would that require a change in government strategy? Does that send the message that, look, ballooning costs are fine and we'll just cover it?
Yes, and yes. Right. I mean, the up till now, both UKRI, Ian Chapman, and STFC, Michelle Doherty, who works for Ian, have stuck to the line, as you would expect good civil servants to do. Decisions were made, unfortunate decisions were made a few years ago. We're now having to deal with those as best we can. This will result in years of pain, difficult 2 years for physics. And this is all a terrible situation in which we find ourselves due to terrible things. What it doesn't say is that we've looked at ways to alleviate it and decided not to. Yeah. So there's going to be quite a lot of push on that. Like I said, the existence of UKRI could, were the political will to be there, could allow STFC's problems to be alleviated, maybe not entirely solved, but made less acute, without any new money from the Treasury, simply by taking some of UKRI's allocation for as yet uncommitted future projects and saying, we don't like the precedent that this sets, and we don't want anybody else to be, over planning in the same way. But for this one case, to avoid this decimation of an important part of our research base, we will take special measures. And to avoid this happening again, we'll also put new oversight in place, or we'll do whatever it needs to be done to reassure ourselves.
Like you said, maybe the hand tying happens again.
Maybe the hand tying happens again. Maybe Michelle has to have a Treasury person sitting on her shoulder all day and all night just to make sure she doesn't sin again. These kind of things happen. There's what's called special measures that councils get into if they overspend, for example, and you could put STFC in special measures, and it wouldn't be allowed to make a commitment over £10,000 without somebody.
You get sent to your room, like you said.
You get sent to your room, but you're still allowed dinner. So that would be a positive that came out of the existence of UKRI, because you don't need to go back to the Treasury and ask them to carry the allocation. You've got a budget allocation UKRI-wide. Now, I was going to say something a bit cynical. I'll say it anyway, right? This is a government that knows how to U-turn. This, even if it did require new commitments from the Treasury, our current UK government has not really stuck to its principles on spending commitments in a number of other areas. And one gets the sense that some of these decisions may not have been thought through in terms of the public impact and the public perception. Yeah. And I think you could imagine somebody sitting in the Treasury looking at the number of scientists who are active in the UK in particle physics and astronomy and saying, this is a relatively small community. They are, researching the Higgs. That's great stuff in terms of future Nobel Prizes, but it's not going to solve our productivity crisis or build new warships or do any of the things that we really want public money to be dealing with at this point. So let's let them live with this pain.
Yeah.
And what they have forgotten is that for much of the public, for many young people, for a lot of our university recruiters, astronomy, space science, particle physics, nuclear physics, these are the things that attract young people into scientific, technical, engineering careers. I mean, we did a survey at the IOP a bit over 10 years ago with undergraduates at University College London and asked them, why did you decide to study physics? Yeah. Something like 90% said because we were interested in space or astronomy or CERN. And these are people who go on to careers in material science or building wind turbines or supporting researchers in biomedical physics or curing cancer, doing all kinds of things. But they get into it. Yeah. Brian Cox, Chris Lintott, because of CERN, because of the excitement that these fields generate.
So it's all well and good saying, we want more people working in AI. We want more people working in material science. But the way you get them is by having these projects, these exciting visions.
I think big science projects, and maybe that's unfair. Maybe that reflects badly on the ability of some other areas of science to sell themselves. But why not embrace this? Why not welcome the fact that
people have disparate interests, and different ways of getting into it?
Big physics is exciting, emotionally inspiring.
Yeah.
Building, 100-kilometer machine, as CERN is proposing to do, gets people fascinated and involved in physical sciences and engineering in ways that we should be using nationally to attract young people into science. And it also sends a bigger, fuzzier message that the government is not really supporting science on the ground. In ways that live up to the rhetorical language about how central science is to our future growth. Yeah. So if science is central to your future growth, you really don't want to be cutting an area that's very prominent externally by 30%. It's going to have a very negative perception of whether you can be trusted to follow through on any other commitments that you might have made internationally, on any other commitments that you might have made to universities. And indeed, as you hinted earlier, and we didn't follow up, we know that other projects are likely to be looking at reductions in funding that haven't yet been announced. So it's all going to risk creating a picture of a government which is saying one thing and doing another. Absolutely. Which is trying to look as if it supports science, but is actually allowing it to be cut on the ground, and which is not aware of the message that this sends externally.
So are these, that raises a good question. Are these cuts final? Because obviously we've seen an awful lot of pushback. We've seen pushback from the Institute of Physics. We've seen pushback, as you mentioned, from the Astronomical Society. We've seen people like Brian Cox come out and say that he doesn't believe, believes this is a mistake along the lines of the 2008 debacle that you mentioned, and that this might not stand. What is your sense of how final this is? Because
I don't think anything is final ever, because certainly with grants funding, the new competitions have not yet opened. The amount of money that's available has been announced, but that can be changed. Nobody has yet been told that their grant is not going to be funded. For some of the big research projects, one needs to move quickly. If we're going to continue to participate in LHCb, then there needs to be a relatively fast, on a timescale of a month or so, acknowledgement that pulling out is not final. But nothing should be regarded as done, dusted, and irrecoverable, even if a year from now we're still arguing about this, because extra money can always be added later to put some of these things. We're talking about big multi-year projects. We're talking about funding for universities. The universities are not going to go away, and as long as if measures could be put in place to add some extra money in a few months, that would still be very, very welcome. And what I think does need to happen quickly is a sense of unhappiness, not just acceptance. If one accepts it, and there's no political pressure to do anything different. If one does not accept it, then it's a problem that needs to be solved. And you can imagine that the more political people, all of this news, I should say, of course, has been completely swamped in the current news cycle by Peter Mandelson. And the question,
of course,
is our prime minister going to step down? Is his chief advisor going to step down? Is anything, what the hell is happening at all? So talking to people in the news media, they say, well, this is great, but it's really hard to get anything on the front page right now. And that's unfortunate. But hey, this is the cards we've been dealt. I don't think there's a conspiracy going on there at all. But the research communities, the affected communities, need to make their case. They need to make the first case that needs to be made is, we are not happy with this. This is not acceptable. This is not a good outcome, and it's not something that we intend to let lie. And as you said, some of the professional bodies like the Institute of Physics and the Royal Astronomical Society have been very good at that. But it would be great if physics teachers, if viewers of your YouTube channel could write to their MPs and say, hey guys, maybe you haven't heard with all this excitement about Mandelstam and Epstein, but there's a big crisis brewing in the UK's physics, support for physics, physics education, physics training, and physics projects. And it's not a good thing to allow to happen just because our attention span is distracted. This is a 30% cut in funding for university research groups active in these areas might well mean that 5 years from now, we are not able to field that workforce that these AI companies need. We're not able to provide the skilled engineers and technicians that are required to grow our defense capabilities in drones and AI. We're not. It's an indirect pathway.
Yes.
Attracting people into physics is the first step in underpinning a whole lot of careers that everybody would see as important. And it's exciting and it's fun.
Yeah.
Don't want to send a message that the UK is giving up on frontier physics just because of some planning mistake that was made in 2022. It would be monumentally stupid, shooting ourselves in the foot. Now, we have lots of practice and bandages on our feet from occasions in the past when we've done this, but here's an opportunity before the foot is actually hit by a bullet to move it out of the way.
So you kind of alluded to some of them there. What would you, if I said to you, what do you think are the worst consequences of this? Because obviously we're going to lose these amazing projects. Some of them won't even be able to go ahead, or they'll have to move into a diminished capacity. We're going to have less scientists on the ground. What would you say are the biggest, the most devastating consequences of this? Is it loss of reputation on the world stage? Loss of ability to attract new postdocs and PhD students? What are the worst consequences of this if it stands?
Yeah, so it's important to say the worst consequence is absolutely not that particle physics and astronomy has to live with less money. That sounds a little bit, university researchers funded by the government complaining that they'll get less money from the government. So, that's a shame, but it's not why this is a problem. This is a problem because we need young people to enter into degrees, degree level study, undergraduate degrees, master's degrees, advanced degrees, professional training in physical sciences and engineering. And we know that these kind of projects and these kind of subject areas attract those young people. Yeah. And if we cut the number, if we restrict the pipeline, we know it's a leaky pipeline already that people go off and do other things. We already have you scientists and engineers for our future ambition. And why on earth would we voluntarily reduce that supply any further? The second point, as you mentioned, is it shows that the UK is not to be trusted. We're saying one thing and doing another. And that's not just about science, it's about government commitments overall. That all of this fine talk about being a science superpower and planning our future economic future plans to deal with difficult economic world situation and having more need for research capability within the UK, all of that is just nice language.
Rhetoric.
It's things to say on the 9 o'clock news, but when you actually enact your decisions, you're doing something entirely different. And that's just so bad. It's bad for scientists. When we go to conferences, everybody is going to be saying, well, you might say you want to be part of this future project, the FCC, for example. How do we know that your government isn't just going to cut your budget in the future? You've done it already. And why would that happen? What's the point of being part of CERN if we can't live up to our commitments that we've made on the international stage? It makes us all look stupid. It makes us all look dumb. And it makes us untrusted. UK is seen as a good trusted partner because we come through with our commitments. We don't want to look like a country that promises something and then fails to deliver it. It would take years to it takes 6 months to gain that reputation and 6 years to lose it. And we don't, and the same thing in terms of support for science, probably already ingrained in certain people's minds that you can't trust the government, even if we can reverse this particular thing. So don't make it worse for the sake of a few tens of millions of pounds, which is absolute chicken feed on the scale of UKRI's £8 billion budget. Don't make it worse. Don't do things that will take years to recover from just to save a few tens of millions.
So that brings us to perhaps a little bit of a spicier question, shall we say, is could these cuts have been avoided? Was this inevitable? Given the shift in government focus, we want to come onto these and put more money into these fields that we see are closer to creating economic growth, rising energy prices. We couldn't deal with this. Or was this poor management? Was this poor forward planning? Or is it a mix of the two? Was this inevitable?
Some level of pain was probably inevitable, because there are things happening in the external world that nobody could have anticipated and nobody could have planned for. But there's also some legitimate questions that can be asked. I'm trying to phrase this in as neutral a way as I can.
And I'm trying to get you riled up at the same time.
Exactly.
Yeah,
so I'm trying to unravel myself.
Not intentionally, but just...
You could well point a finger at decisions that were made 3 years ago about committing to future projects, if the only way that you could deliver those future projects was to secure a big budget increase in the future, because that is a risky proposition at the best. It's like me going out and saying, I want to lease a Ferrari, and I'm basing my ability to pay for this on the fact that I'll get a pay increase next year.
Yeah.
Maybe I will, maybe I won't. What if I don't?
Yeah.
And that's kind of what's happened here. The STFC pre-committed to paying for a number of things on the basis that it would get a pay increase, and it didn't. And that's not wise. It's not, especially in the current economic climate. That wouldn't be my plan A.
So you can understand why people have done it. We want to do exciting science. We want to have these big projects, but we have to also realize the political reality.
It would have been painful, but a lot more honest to have told LHCB, the UK LHCB, I'm sorry, we do not expect to have a budget in the future that is big enough to allow us to do what you're proposing to do. That would have been a difficult message. It would have been an unpleasant message 5 years ago, but it would have been a lot better time to have that discussion than now.
And we can lament, look, science should get more money in this, but within the reality of things, this is the harsh message that you have.
I hope that measures can be taken to reduce, so you've got that some amount of pain, as I said, is inevitable, but the impact, especially a 30% reduction of grant funding on universities, seems disproportionate to the amount of money that's being saved. And that would be my highest priority to try and fix. My second highest priority to try and fix will be these projects where we've got international collaborators who are going to be let down. And so that's half of the overall budget problem that we've got. If something like that could be alleviated as a partial way of making the thing less bad, while still acknowledging that some of the savings need to be made, that some of the, you can't allow problems to happen and then simply, have a get out of jail free card. But whatever happens, you'll get the money to cover it. That would encourage so much bad planning in other parts of the research system. So I hope that if enough, let's not say fuss, if enough anger, if enough unhappiness, if enough public relations pressure can be brought to bear on government, on Lord Valence, on Secretary of State, on members of Parliament through the Select Committee, all of these, it has to be somewhat political pressure, but public pressure is political pressure. It will seem like a problem. If it's a political problem, it has to have a political solution. And the political solution is Patrick Valence tapping Ian Chapman on the shoulder. Hey, I know you and I discussed this, and we wanted STFC to solve this problem itself, but it's so painful. It's we're already facing challenges from reform in Manchester constituencies. Jodrell Bank, down the road from where Andy Burnham was forbidden from standing, is going to be hit hard by these cuts, and we just don't want more bad news on a timescale of May. Please fix this. And that, I mean, that sounds a bit grubby. It sounds like a very political answer to what should be a research question, but that, I think, is where the answer lies.
Interesting. Now, but perhaps to where I have to be a little bit, political and a little bit careful, because my old lecturer at Cambridge, Mark Thompson. So do the ballooning costs at STFC reflect poorly on Mark Thompson, who is now the DG of CERN? So he's now tasked with securing international funding for the future Circular Collider program at CERN. Do you think this will have a knock-on effect where nations might be wary regarding his management? Will this situation have an even larger knock-on effect on particle physics? Will nations think, are costs going to get out of hand again with the same management? Do you think there's a deeper problem here?
This question is bound to be asked, and I think that but it'll be answered in different ways by different audiences. I understand enough about the role that Mark held at STFC to know how these things can occur. Like I said, I think there might have been other ways to have handled some of these projects in ways that didn't pre-commit quite so much. But I can see why he wanted to do that, because if you don't ask in this environment, you don't get.
You don't get, yeah.
And to decide already to curtail your ambition at a time when I think STFC was being told to plan ambitiously for the future, and therefore needed to come up with interesting future projects to do. So I do think, however, that to those who don't know anything about the context, Mark's
involvement, you can say, same person here,
prior
same person
involvement
there.
in this is, people are going to say, hey, hold on, what's happened in the UK? You got out just in time, didn't you, Mark? Kind of thing. And this it's going to be treated as a little bit of him leaving a Pandora's box that Michel Doherty then opened, and all these devils jumped out.
If you were cynical, you could say Fabiola's done that to him now, right?
Exactly. And Fabiola may very well have done the same thing to him in terms of the cost for FCC, but he is where he is. Nobody's going to say he's not the right person for the job at CERN, but they are going to say, can we trust the UK in contributing to CERN if it pulls out of reneges on its commitment to LHCb? And as you said, is Mark Thompson somehow, is his reputation with the UK government called into question by this? I was reminded by one of my colleagues that in the US Navy, if you're the commanding officer of a ship and the ship runs aground, you're immediately relieved of your command. There's no question about whether you're responsible or not. You're simply responsible by virtue of having that job. And I don't think anybody's suggesting that Mark Thompson should be, relieved of his command in the same sense. But if you're the chief executive of STFC, and
someone
STFC
carries the can, it's like the manager of a football
buck stops
team,
here, right? Whether it's your buck or anybody else. Now, Michel Doherty is now carrying the can, but it's clear that the can is the result of decisions that were taken years ago. Like I said, I can understand how those decisions get made, but to an external audience, those questions still need to be asked. And it's especially unfortunate then that one of the projects which is itself in scrutiny is LHCb at CERN, which just means the whole thing is inescapable, and nobody can avoid asking this question, and the whole thing looks like a bigger mess, right?
On the flip side of that, do you think, in terms of the government over here in the UK, do you think some of Ian Chapman's comments potentially threw him under the bus for a change in government strategy as well? It was just kind of like, "Mo, you've let this get out of hand."
I think Ian is first of all trying to keep the focus on what he wants to do going forward, and you saw this in his select committee appearance. He didn't want to get dragged down into what he probably sees as the details of STFC planning on particular projects, especially as he's relatively new in the role, and a lot of these decisions were made. A lot of this potential crisis was known about before he was even appointed. Now that means he should have known about it too, and I'm sure he did. But he feels that it's a distraction from his forward-looking program, and these are backward problems that he's inherited rather than forward challenges that he wants to address. But equally, he's in charge, right? He's responsible for everything that happens in UKRI. He's the accounting officer in technical terms for that entire budget. And that means that if Michel is not, and that means if a grant gets issued to a university, ultimately Ian is in the approval chain for that. He can't shirk that responsibility. He has to stand up and justify why this is a strategic direction that he thinks is right for the UK, if indeed he does. And if he doesn't think it's right for the UK, he's got the tools and levers to change it.
So you mentioned what you did back in 2007, 2008, when a similar thing happened. And you also gave a few ideas about protecting grants and such. What can we do to minimise the damage in the short term and recover the UK scientific reputation, in the longer term? Because we seem to be at a little bit of a low ebb here.
Exactly. The faster steps are taken to address this, the less damage has to be recovered.
What would you do then? You've sat in a few of these big chairs. What would you do right now? What would we do?
I'd be quietly encourage. I think Michelle is in a very difficult position because she is bound by collective decision making in UKRI, and it's very hard for her to go and argue with members of Parliament, for example, that the UKRI has done the wrong thing. So she's been tasked to do whatever she may think And however strongly she may have argued a year ago that this was an unacceptable outcome,
because she has an astronomy background as
she
well,
missed
right?
her opportunity. Sorry, this is going to sound glib, but she missed her opportunity to resign a year ago, or 6 months ago when the spending review allocations came out. She could have said, "This is so bad. I can't do this. I refuse to do it. It's incompatible with my role as astronomer role, and I'm not going to do it." But she decided she was going to stay at STFC and try to make the best of a bad situation, and maybe she felt that was what she could and should do. But it ties her hands. She can't lobby against the government. She can't. So it depends upon universities, public, MPs, people like Brian Cox, people like Chris Lintott, making enough of a fuss.
Yeah.
The internal people in STFC cannot do that. They will risk losing their jobs.
Yeah.
I think some of them will quietly slip their friends information that will be helpful. Freedom of information requests, journalists chasing it, not letting the story die, because government survives by outliving the news cycle. If something used to be news and it's no longer news, it's not a crisis and we don't have to solve it. Those who care about this deeply need to make sure it is still a crisis and therefore it needs to be solved, and it's not going to be allowed to be forgotten. The biggest risk here is that it gets forgotten in the UK political system, and then the scientists have to live with it. People who in the university system risk losing their jobs because the funding has gone down. Entire university groups risk being disbanded. UK's reputation goes to shit, and we don't need to have any of those things happen if we can keep this external pressure on the political decision makers.
Is this how is your time, John? I've got 2 or 3 more questions, maybe 10, 15 minutes.
Fine.
Is that okay?
Let's keep going. Yeah.
Okay. So I want to kind of broaden this out. Is this a worrying wider trend? So is this part of a wider cutting back in science, in particle physics in particular? We've heard concerning messages from the German funders about the FCC program being too expensive. In particle physics, we've seen Italy, France, UK cutting back on particle physics groups. The situation in the US, maybe not for particle physics, as you said, but in other areas is uniquely terrible, perhaps. Just how concerned should we be that this is part of a wider program of cutting back in at least certain areas of science?
Some of this is indeed consistent with that much bigger picture internationally. And you might well say, well, they wouldn't have decided to go ahead with this approach if other areas seem to be dramatically increasing their funding for particle physics. It looks as if it is a sense internationally that these fundamental areas of research need to live with budgets that are not increasing, and maybe live with budgets that are decreasing in real terms, while support for other areas goes up. And a lot of that is what you might call macroeconomic pressures. It's nothing to do with science itself. It's to do with the fact that governments are suddenly having to find a lot more money for other things, defense most noticeably. But to be fair, the UK spends a lot more on research than it does on defense. And what we're talking about is increasing defense spendings as something similar to the level of research spending. So that, the idea that the defense people get everything they ask for is not actually true.
We heard Ian Chapman say something I found a little bit, I don't know, I just didn't like the sound of it. He said that we need to sweat the scientists to boost economic growth.
Yeah,
I think there's a bit of a delta between these great intelligent people, they create lots of, economic impact for our country. That's fantastic. When I hear we need to sweat you to kind of grind as much out of you in the scientific minds as am I being naive? This is why
yes,
science is being funded, to make money for the government.
No, you're being naive, but you're also right. There's a whole podcast here, and maybe we could do that sometime. In what political scientists would call the post-war economic settlement. After 1945, especially in the United States, very influential science advisor Vannevar Bush proposed that the best way to ensure future economic competitiveness for the United States, and this is a model that most other Western countries then followed, was to support pure research through the basis of peer-reviewed proposals and not ask too directly for economic impact.
What are the spin-off technologies? What are you doing?
You get the spin-offs in due time.
Yeah.
But you don't ask for them to. Now, in the US, that was coupled with a lot of investment in defense R&D and a lot of investment in national laboratories, which ensured that there was a Defense Advanced Research Project Agency and other things. So it certainly wasn't the way they funded defense R&D, but the way they funded civilian R&D in the natural sciences, in the National Science Foundation, in the National Institutes of Health and other areas, was to ask researchers, what's the best research to do in your area and to support it? What Chapman is reacting to is a feeling that model may have run its course, or it may have got over dominant in our research system, because the UK does not fund a lot of these other areas like the US does, like DARPA and defense R&D. And we also, there's a sort of feeling that isn't quite crystallized, that the economic and geopolitical challenges. What if the United States pulls out of NATO and we have to spend a lot defending ourselves? Those things come closer to requiring a sort of COVID type response, where we just say we've got a certain amount of scientific expertise and how are we going to use it best to address these problems? It's that not quite an emergency, but a brewing crisis. And the words that Chapman says make sense if you think of it as, we know that some really bad things are coming on a timescale of 5 years. And how can I start to mobilize, maybe sweat is the very wrong word, mobilize the science capabilities that we've already got in support of that? Now, I think a lot of...
Does that defocus this kind of, blue sky research then and make you go more focused into AI, into defense technology?
It might, this kind of thing? But then you need a proper strategy for how you're going to do that. And the government has produced its industrial strategy, and it does talk about those areas like AI, but also material science, and it does not talk about particle physics and astronomy. But it should remember, as we were saying earlier, that part of the skills pipeline that you need for those things is to recruit particle physicists and astronomers. So what I think these words should be read in the context of is, it's not business as usual. It's not the world that we used to know.
Yeah.
You don't know what the new world is, but we need to be ready for it to be a bit crisis prone, and one where our national research capability, whatever that means, which resides in universities predominantly, is seen as a national resource and might need to be told what to do. Now, university professors are not good at being told what to do. The job involves a lot of persuading. But it is quite possible that new funding routes and new ways of supporting research, which is what Chapman is talking about, that aren't this peer-reviewed, proposal-driven National Science Foundation model, will have to come into play. But then it needs to be very clear what the goals of those projects are. So suppose you're being funded to develop an autonomous swarm of drones that can perform surveillance over the Estonian border with Russia or something. You need to know that that's an outcome. That's the goal of success of the project is, does this swarm of drones work? And that's much more applied. It's much, it may be the same sort of AI software work, but it's a very different goal for success than, can I publish in AI journals? In fact, we wouldn't be allowed to publish at all. So this is a real shift in the way that the research base works. It's something like 1939. It's people in government are seriously using words like plan for the UK to be at war, maybe a low-level war, maybe NATO at war, but war footing within 5 years. We hope it doesn't happen. By planning for it, we hope we can deter it. And that, if you're serious about that, then you start to do the things that Ian Chapman is talking about. But doing it without that kind of context sounds weird. And I think the British public hasn't really been, or isn't really ready to be, to have that conversation yet. It sounds like it's coming from some weird, slightly crazy general when he says that. It doesn't fit into our sense of the pressing problems that we face right now. And if that's serious government thinking, they need to motivate a bit better than they have done so far.
So that kind of leads me on then, John, to something that's perhaps a little bit closer to our hearts then. So are particle physicists in particular losing that PR war? Are they losing that war to convince funders, to convince governments that particle physics delivers tangible benefits to taxpayers, to the public, to that asset base, like you said? For want of a better way of putting it, John, is Sabine winning?
I wouldn't say Sabine is winning, because I don't think she has a clear sense of what winning is. But it's
are we losing?
Particle physicists are losing prominence in that debate. It doesn't necessarily mean that the arguments aren't good. It means that they don't seem tied to the right timescales.
Right.
The benefits of the FCC
we can sell the return on investment. We can sell
many
all these technologies, but when and in what?
Many decades. So if you are in the National Security Council in Whitehall and you are listening to people who are worrying about what can we do to protect aircraft carriers in 5 years' time, you're certainly not looking at FCC to deliver benefits on that.
You're not looking at the Higgs width measurement and saying...
Well, you're never looking at the Higgs width measurement as an economic benefit, but maybe you're looking at higher field magnets, or one of the things that will come out of the technologies that are needed to build FCC HH. But that doesn't happen until the 2030s. There's so much R&D needed on those in the meantime. And I think it's this change in timescales. It's this, imagine that they're thinking of it like COVID. When the pandemic came and we had to think of ways to make ventilators very quickly or ways to develop vaccines very quickly, it wasn't about research, it was about development. It was about using technologies and factories that already existed for purposes that technologists who could come up with, people from Dyson who knew about fans, who could design ventilators, and so on and so on. Particle physicists were involved in that by doing things that use their expertise, detector expertise that could be applied to imaging, for example, and could be used to understanding, what's being seen in X-ray diffraction images or whatever. But it's not the particle physics itself. It's the training benefits and the people. And so we know this is a benefit that never gets talked about a lot. But we know that a lot of the people who work in secure communications, who work for GCHQ, who work for the security services and MI6 and so on, have a physics background. Because, and of course they don't talk about it, and they never show up in the economic impact assessments because they're not allowed to talk about what they do. But we know that when you're trying to design, secure quantum communication between satellites, when you're trying to do cryptography, you are using the skills that big data, large experiments at the LHC have what do we say, have brought to the fore.
That skilled workforce that you've...
The skilled workforce training is, but again, if you start training people now, they're just graduating in 3 years' time, 5 years' time. So the pipeline, you must not hit the pipeline now. So I don't think particle physics has lost the argument, and it's certainly not with the public, but it risks losing the timescale argument. And that is quite critical then when governmental priorities shift to short-term problems. And those are not just defense problems. Those are economic growth problems. What can we do to deal with, UK productivity has stagnated. How can we help that with AI? It's not AI you might have in 15 years running on a quantum computer that doesn't yet exist. Is what can you do with today's...
And of course, that doesn't help a Labour government that wants something right now to look better in the public side and the short horizons.
In my day job, the stuff that I'm doing with Scottish universities, and it's about what can be announced on a timescale of May, because that's when the Scottish elections are. So there's nothing that the FCC can do on a timescale of May. You wouldn't want to suggest there was. So you have to say what we can do by May is announce prudent investment strategy that will underpin the skills that we need. And skills is probably the best way for particle physics to sell its impact on timescales that are relevant politically right now.
Absolutely. So if I come to a final question, John, so we've talked through everything is terrible, everything is awful. Let's try and finish with as positive an outlook as we can. Where do we go from here? What can we do better? Where's the hope, John? Where's the hope?
The hope is that the hope is that we're talking about it, right? We and many other people are talking about this as a problem. Because if we can create a public upswelling of unhappiness about major reductions to support for fundamental science, those reductions will not happen. There is power in numbers that, turn all those blue faces yellow, get them marching, get them writing to their MPs, get every physics student, get every physics teacher in the country writing to the Institute of Physics saying, we don't want this to happen. It's not a decision that's irreversible. If it is, even if it isn't reversed, there is a lot that we can do to show that we can communicate the positive messages about fundamental physics using this hopefully bad thing that hopefully we can avert as a way to draw attention to the risks.
Superb. John, thank you so much for taking time. I really, really appreciate it.
As always, Sam, thanks. And just, message to you out there watching. Don't take this as a something you turn off and forget having seen it. If what we've talked about feels like it's something that should not be allowed to go ahead, there are things you can do, even if it's just writing to Brian Cox or trying to get your physics teacher to, have some thinking with the Institute of Physics about how we can make sure that this doesn't just get allowed to go unchallenged. So thanks very much to everybody who can do that.
Absolutely. Everyone out there, you have some power to affect some change in this. So
Social media is something the government doesn't quite know how to handle, and creating that pressure through these routes is actually very, very powerful.
Absolutely. John, thank you so much again. I know you've got to run for another meeting.
And the reason, just again, to put a slightly different positive spin, the reason this is so frustrating is that we know that UK science is really good. And we know that the contributions that we're making to these projects are really important and central to their success. And we don't want to see that thrown away.
Absolutely. John, thank you so much again. Have a wonderful afternoon and a wonderful weekend. And we'll chat again soon, buddy.
Thanks. Bye-bye.
Take care. Bye now. Take care. I want to know what you think, because you're the scholars of enlightenment that I do this for. So please take a moment, if you wish, to let me know down in the comment section. And if you like this video, please consider leaving a like, subscribing, setting up notifications, and sharing this video more widely. I can't tell you how much these simple actions help me out and how much I'd appreciate it. Thanks for watching. Thanks for being scientific. Thanks for being bad.